Let's break down the AI backend architecture that is going to define the next 2 years. This is about what separates the companies that scale from the ones that, well, won't.
Most AI startups are building their backend wrong, and in 2 years, most of them won't survive because of it. Now, that's not a prediction based on hype. It's an observation based on infrastructure fundamentals.
All right, here's how we're going to break this down. First, the looming economic problem, then why the current API-only approach is set to break. We'll introduce the architecture of 2026, walk through its 5 intelligent layers, and finish with where the real moat actually is. So the core issue, the thing that's going to break most AI products, it's not the tech. It's not about capability. It all comes down to unit economics. Think about it. When your whole backend is just a thin wrapper around some third-party API, you've handed over the keys. You don't control your cost of goods sold. Your provider can change the price whenever they feel like it. You don't control latency. You certainly don't control their roadmap. And what does that lead to? Well, your margins get squeezed, token inflation eats you alive, and the cost of these giant context windows just explodes. It's not a sustainable model.
It really is this simple. If your entire product depends on someone else's inference cost, you do not control your margins. That's it. It's an unavoidable business reality.
Okay, so let's look at the default architecture that pretty much everyone's using and really understand precisely why it's a dead end. The common pattern is predictable. A client sends a request. Your backend does a tiny bit of processing. It makes an outbound call to an LLM API, sits there and waits, and then sends the response back. It's simple, it's linear, and it is deeply inefficient. And this approach is just fundamentally brittle. It's stateless, so there's no intelligent caching. There is zero routing logic to handle different requests efficiently. What happens if the API goes down? There's no fallback. There's no real strategy for context compression, no control over inference. You're just completely locked in and dependent on a single vendor.
So what's the alternative? What replaces this? It's what you could call a cost-aware hybrid AI system. And let's be clear, this isn't just a better approach. It's really the only one that's viable if you're serious about scale.
This kind of architecture is built on 5 key intelligent layers. You've got a request router, a context engineering layer, a multi-model strategy, cost-aware orchestration, and finally, a solid feedback and observability loop. We're going to walk through each one. All right, let's get into the details of these 5 layers and see how they come together to build a backend that's actually robust and scalable. First up, layer 1, the intelligent router. You can think of it as the heart of the system. Its main job is to ask one critical question before making an expensive API call. Do we even need a large model for this task? A lot of the time, the answer is no. A simple business rule or an embedding lookup or even a tiny, cheap local model can handle it. Just getting this one layer right can reduce your cost by 40, even 70%. Next is layer 2, the context engineering layer. And look, this is way more than just basic retrieval augmented generation. A mature system performs dynamic context pruning and semantic compression. The goal is to send only the most relevant, most impactful tokens to the model. Senior engineering isn't about using the largest context window. It's about using it as efficiently as possible. Layer 3 is all about a multi-model strategy. A serious system doesn't rely on a single giant frontier model for every single task. Instead, you use a fleet of models. You have small, local ones for classification, maybe some medium-sized models for simple reasoning, and you reserve the expensive frontier models only for when they are absolutely required. It's about using the right tool for the job. Okay, layer 4, cost-aware orchestration. This is really where the business logic meets the infrastructure. Every incoming request is treated like a mini project with its own budget, its own service level agreement, and a specific risk level. The system can then decide to escalate a high-risk query to a more powerful model or de-escalate a low-risk one to a much cheaper option. This right here is the hallmark of mature AI infrastructure. And finally, layer 5, the feedback loop and observability. I mean, you can't scale what you can't measure, right? It's a classic engineering principle. This means you're doing token-level logging, tracking prompt performance, monitoring latency, and detecting model drift. This is what allows for continuous improvement and reliability, just like any other serious software system. So all of this builds up to the most important strategic insight, which is where the real defensible moat is actually built. And it's probably not what you think. Routing is the moat, not the model. The winning companies won't be the ones with slightly better prompts. They will be the ones with the most intelligent, efficient, and cost-effective routing systems. Period. And this table summarizes the trade-offs clearly. The API-only approach, low margins, limited scalability, basically no moat. Self-hosting is complex, even if the margins are high. But this hybrid, intelligent architecture, that's the only one that really delivers on all three fronts. High margins, high scalability, and a strong defensible moat. And you can see this is just the natural maturation of the industry. 2023 was all about just getting access to models. 2024 is about agents and prompting. 2025 will be defined by orchestration. And by 2026, this game will be won or lost on infrastructure strategy. Look, most developers are going to ignore this. They'll continue to build simple API wrappers because it's easy. Serious engineers won't. They will build the systems that are designed to scale and to endure.